Now let's see how to work this problem on the board. It involves critical angle, in fact. So let's know what exactly critical angle is. Let's talk about this thing. It's all about refraction, but this time we have light traveling from, let's say, denser medium to rarer medium, and that is I and that is R. Definitely light would bend away from the normal, we know that. So let's say light bends away from the normal, that's I and that is R. Now what if I increase the angle of incidence? Let's say I draw it with dotted lines like this. So if I increase the angle of incidence, the angle of refraction will also increase. There would be a particular time where if I increase this angle in such a way, let's say I draw small dots here, this angle of refraction will actually be on the surface, and this is what exactly I want. This angle is called as critical angle, right? So that it is that angle for which the refracted angle is 90 degrees. That's all about it. Now if you put Snell's law here, right? Snell's law, it says sine I by sine R is refractive index of second medium. Let's say this guy is N2, this guy is N1. Right? Why is N1? Because light is traveling from this medium to this medium. Alright, so refractive index of the second medium, that is N2, divided by the refractive index of the first medium, that is N1. That's all it is. Now I can see that I is the angle of incidence, and in this case I is C. Alright, the critical angle, and R is 90 degrees if I'm talking about the critical angle. So I can write sine C divided by sine 90 is equal to N2 by N1. Very simple. Now if I cross multiply this, sine 90 is anyway 1, so I'll get sine C is N2 by N1, and N1 into sine C is nothing but N2. Okay, this is the relation I would be looking for and I'll be using in the following problem. Okay, let me erase this for you. Have a good knowledge about this before we can actually attempt this problem. All right. Alright, now let's see how to solve this problem based on what we just learned about critical angle. It says a critical angle of incidence for a glass slab immersed in water is 60 degrees. So in fact, there is a tank. Let us draw the picture, and there is water out here, and there is a glass slab immersed into water. It means the glass slab is somewhere here. Right, exactly, this is what I'm talking about. This is glass slab and this is water all the way around. Fine, correct? Now critical angle is given as 60. It means what? If at all I draw a normal here and there is some light here which follow like this, and that's the critical angle is talking about, 60 degrees, and light would gaze out like that. R is how much? 90. That's what it's talking about. Right. What is critical angle when it is immersed in a different liquid? Okay, this guy is water, so N of water is basically 4 by 3. You guys should know this, it's a constant. Now it's giving another set of conditions. What is the critical angle of the same glass when it is immersed in another liquid? So let's talk about another liquid here. It says, I'm changing the liquid. I don't know what is the refractive index of this liquid. So, okay, it's given to me. Refractive index of this liquid is √2. Let's say N liquid is √2, and the same glass slab is here, but this time I don't know what is this angle. This angle I don't know. Here the angle is given to me as 60. Here I don't know this angle. This is what I'm supposed to find out. What is the critical angle? That's my question. But I know that this guy is anyway 90 because he's telling that this is critical angle. All right, that's the whole condition. How do I solve this problem? My whole idea is to find this guy. All right, now let's come back to this and put Snell's law here and see what happens. Snell's law says sine I by sine R is refractive index of second medium. So this is the first medium and this is the second medium. So that is refractive index of water divided by refractive index of glass. All right, which I don't know. All right, I know this guy. I know I is supposed to be 60 and R is 90 degrees because it is refracted angle has to be 90. This much I know. So let me put these values here, sine of 60 divided by sine of 90, which is 1, and NW is 4 by 3 divided by NG. Okay, so one thing I don't know here is NG. I can find this out. We'll see what happens here. In this case, again, I don't know what is the refractive index of this guy, and refractive index this guy is given to me as root 2. This I don't know. Again, C, let's say we call it C dash, I don't know this, and this guy is anyway 90. So put sines now here, what happens? It says sine I by sine R is refractive index of the second guy, that is N liquid, divided by refractive index of the glass, which I don't know. So what is sine I? I don't know. Let's say is C dash divided by sine 90 again is equal to NL is root 2, and NG is what I don't know. Okay, that's the whole idea. Come back to this. Let us raise this a little bit so that I can solve it here. Can I solve this information and find NG so that I can use it there? Look at this. So I know sine 60 by 1 is 4 by 3 divided by NG. So I write NG is equal to 4 by 3 divided by sine 60. If you solve this, you will get a value NG to be 1.54. Just solve this guy using log tables. 4 by 3 into sine 60, whatever it comes, which will give you 1.54. Okay, I got NG. All right, now come back to this guy. From here, I'm looking for C dash. So N sine of C dash by 1 is equal to N, that is root 2 divided by NG is 1.54. Now let's see what is sine C dash. That is, if I divide these two guys, I'll get something like 1.414 divided by 1.54, that is 0.9182. all right, you got to do this, guys, with your own calculators, and logbooks is very important. Now how do you find sine C dash? Put sine on the side. C dash is a sine inverse of 0.9182. that comes up to 66 degrees and 40 minutes if you know how to look into the logbook. Now let me summarize the problem. See, what happens here is this. He's giving two conditions. He's giving you two conditions in the same problem. Okay, in the first condition he's giving you values like I and R is something that you know, and he's giving you NW, or if he doesn't give you also, if he mentions water, it is 4 by 3, we know this. The only thing missing is NG. But why is he giving this whole condition? So that I can find NG and use NG in this condition. This is how typical problems in physics generally being asked, that they'll give you two conditions, and from one set of conditions you will find one of the values and use the same value in the second set of conditions, where I can see that here C and NG both are unknown, so I cannot solve it, right? But my question says to find C dash, that is critical angle, but to find this I need NG, and in this set of conditions NG is not given. That is why the first set of conditions are given. Find NG from this and substitute there. This is a simple trick they follow into numericals and physics. I hope you understand this. Try doing more problems, and whenever you get two set of conditions, draw them separately and solve them separately, and see how you can find something from the first conditions and substitute in the second condition. That's all about it.